Well, good morning, Sherry.
Good morning, Rasmus.
And good morning, all. Um, a warm welcome. Thanks for joining us here today. I really appreciate you taking the time out on this very busy morning. And
But beautiful and
oh
sunny.
yeah, we are in luck with the weather. Lucky we will be inside.
Yeah, that's true.
So I think the weather says 7 degrees here in Copenhagen.
Yeah, but it was frozen in the morning. My car was frozen, so
Yeah.
I had issue to open the door.
But I can imagine people are joining from most of Europe, actually.
That's great.
So we have guests from Netherlands, I can see, Sweden. Hello, Sweden. Thanks for joining. And I'm sure from around Europe. So thanks a lot for taking the time, right? We have this morning together, a good 3 hours.
Mm-hmm.
And I wanted to call it a conference.
Yes, it is a conference.
Yeah. So we have done what we can to make it feel like a conference and act like a conference. But of course, we can't be together right now.
Yeah, that's a pity. But we are here and we have a chat. Actually, we can talk each other. We can interact in the chat, and also you can all talk to what we are have discussion here. You can also continue the discussion in the chat as well.
Awesome. So maybe first we say hi.
So my name is Sherry Liz, and I'm working as Azure Developer Engagement Lead at Microsoft, and I'm one of your co-hosts together with the awesome Rasmus.
Yeah, hi guys. I'm Rasmus. I head up the Cloud Center of Excellence at Maersk. So as you can imagine, this is not my day job, but I also spend a lot of time in the community and just sharing knowledge sharing learnings, both from my work and what I've learned in the past. And today is brought to you by actually the Azure user group in Denmark and also the DevOps user group in Copenhagen.
Which you both are the co-organizer in both of them.
Yeah. I love cloud. I'm a cloud hugger, but I'm also a DevOps hugger. So I really appreciate good practices and awesome technology.
Yes.
So how about we take a look at the agenda now?
So after we are done with the opening, we are going to have our first speaker, Bas from GitHub, that he's going to have a talk about cloud to cloud with GitHub, which is going to be super awesome. And right after that, we have Wakas Ali from Maersk that he's going to show us how they're using infrastructure as a code at Maersk. There's a lot of secrets actually in this talk that which aligns together with our team, which is DevOps Secrets. Then we are going to have a short break. And then during that break, we are also going to have more of the Azure Secrets as well, and then you are right after that. We have our last talk with René. That is when we are down is not good enough. So we are going to have a conversation about the SRE. The thing is that we don't have the section, the Q&A after each talk. What we want you to do is that you write all the questions that you have in the chat, and we are going them back during our panel discussion where we have all three speakers there, and there will be some prize as well, which Cosmos is going to talk about it as well. And after that, we are going to have an outro and say goodbye to you all.
Yeah. So as you mentioned, we have prizes because we have sponsors.
Yes.
and we were lucky enough to get GitHub to sponsor some swag for today, some giveaways. So they will potentially be going your way. And Microsoft sponsors, thank you.
Welcome. And Maersk sponsors, thank you.
Oh, you're quite welcome. So of course, this is all, I would say, non-profit, right? So it being pulled together by sponsors is important. and hopefully also spicing up your day with some giveaways.
Yes.
So speaking of giveaways, we have quite a program for you. So I would say there's a fair chance that you're walking away with something today.
Yeah.
Hey, it says Badger Secrets.
Yes, we are. So that so there are many ways to get a giveaway. The first one is the Badger Secrets, where is that we are going to give you all an Azure Heroes learner badge, but this time the badger comes with a secret. So the first 10 people that they get the badge, there is a reveal code in their badge, and they can use that reveal code to get an actual swag box from Microsoft. We are going to talk about it at the break, where we also going to have the distributing the kind of those badges, and yeah, so all the details will be there. And
awesome.
What is the panel question?
Well, we want it to be interactive, but we also want to give you a chance or motivate you to ask questions. So we will have a 30 minutes panel at the end. And we encourage you to ask questions. So save your questions, put them on paper or wherever you want to put them. And when we get to the panel section, post your questions. And we have some pretty cool prizes then. I'll share what it is later. And then there's this secret hunt. So
yes.
If you don't mind, I will introduce that now.
Yes, because that's the
cool one, right? So we dusted off these super rare Lego Maersk ships. Wonder who brought them in. So, oh, sorry, we have some slide deck problem this morning. So we actually have 2 of those, and you can win one of them. You just have to, well, I would say stick around for the duration of the conference. So you need to hunt for the secrets, right? So discover the 3 secret words. Funnily enough, we have 3 presentations. And each presentation will contain one of these secrets. And at the end, you will have a chance to submit your answer. So if you have all 3 secrets, submit them together with your email address, and we will draw a winner today or tomorrow. And there you can win one of these ships delivered to your home, of course.
I just remember we have one more way to get the chance to get the swag box.
Oh yeah, the Microsoft swag box,
yes.
Which is pretty awesome.
Feedback form. So at the end of the show, we are going to actually to distribute the link to our feedback form, and we want to have your feedback because we definitely want to improve. And then 3 of you who actually submit the feedback form will get we get also a box delivered to your home address.
Awesome, great. So
feels like Christmas.
Yeah, I know. So we have 5 minutes before Bas joins us here on stage. What should we discuss?
Maybe you can tell us a little bit more about the DevOps.
I would love to. That's a great idea.
You have a chance. 5 minutes and start now.
Okay, great. So DevOps actually comes out of the traditional or bridging the traditional divide between dev and ops and just creating cross-functional teams, right? It isn't really that that mystery sauce, right? So we've been doing DevOps for 10 plus years now. So hopefully there's good knowledge about what DevOps is out there. But it is basically about people and making sure that people are set up in a way to be successful in the software development cycle and the IT delivery cycles. What we often discuss when we talk about DevOps is, what is it? Right? And there's so many different interpretations of what DevOps is, right? Is it automation? Is it infrastructure as code? Kanban, feature switches? Is it a way of organizing teams? And I think we can say that it's all of the above, right? But I also think we can sum it up fairly easily to be about, I would say, people, right? And when we talk about people, it's empowering people to be set up for success, right? So making sure that we organize our teams in constructs where they can actually deliver at the cadence needed by business, right? So instead of us handing over the work between different work centers, so if you have one team creating certificates, another team creating servers, a third team deploying code, why don't we just huddle that team together and make them do it together? Or if we can't, right, we create automation and self-service. So I can subscribe to, well, you're provisioning servers via an API, so I don't have to wait for you. So it's about removing the friction, and therefore people are set up for success. The second part is about processes, which I also translate into practices. So ways of working, right? Different disciplines in modern software development and IT delivery. And I'll dig into that in a second here. And the last part is actually about tools and products, which is, yeah, you should select them afterwards, right? I know we're engineers here on the call today, so we probably start with the tools.
That's true.
And then we figure out the process and the people afterwards. But often, I mean, make sure you're set up for success, learn these practices, and then pick the tools, right? So just quickly on the DevOps practices, and this list is nowhere complete. But we have all these practices, and today we'll talk about infrastructure as code when Rakas joins us in 30 minutes, and go through what we have done at Maersk in setting up this discipline. But this is all about automation at scale, reusability, and making sure that we don't write the same line of code twice. We all know CI, CD disciplines, testing, automated testing. In a second, Bas is going to join us with everyone's favorite tool, GitHub, but actually dig a bit into some of the automated security testing features there, which is also key, right? How do we bake in security now that security is everyone's responsibility? Yes. Site reliability engineering is a discipline. I think it was coined by some of the Google staffs, but there's been a lot of literature around this on setting up reliability engineering as a discipline. And for me, it really is the evolution of the traditional IT operations roles into digital product development. And I know we have adopted this widely at Maersk and are having great successes with that. So you'll see we cover a diverse set of these disciplines today. Of course, we can't cover all of them. But I think we have coring some that are quite interesting, and looking at the sign-ups for today, we are almost at 200, which amazing. Is pretty awesome, yes. Considering that we all have a bit of fatigue, screen fatigue, I would say.
But it's also because it's a very important topic to discuss.
Yeah, I think so. So with that, I think that's a nice segue into our first presenter of today. So let's just welcome to the stage our first speaker. Here we go.
Hi, Bas.
Hi, Bas.
Good morning, Sherry. Good morning, Rasmus.
Good to see you. Thanks for joining.
Yeah, thanks for joining us today.
Thanks for having me.
So, as we all see that Bas is joining us today, and where are you based in, Bas, actually?
I'm based out of Amsterdam, so yeah, I spent most of my time with customers based in the Nordics, but I live in Amsterdam, where GitHub we have an office in Amsterdam, although it's still closed due to COVID, but there's about 30 people working from an Amsterdam office.
Oh, great. So Bas is a solution engineer at GitHub. What actually you do as a solution engineer?
So solutions engineers, we are part of the sales department of GitHub, but we are more, technical people. So we have like a developer background, mm-hmm. And you could say our goal is to help our customers to adopt the GitHub platform. Okay,
great. And then maybe you can say a little bit about what Bas is going to show us today,
I would love to. So I really appreciate you joining us today, where where it's a super hot topic, and the feedback I got on Twitter when I first announced your talk was quite positive. But we're talking about code to cloud with GitHub, and I think there's a security angle to your talk as well, Bas. Is that correct?
Correct. Yeah, I will focus on the security features, although I will also talk a bit about code to cloud with GitHub. But my focus will be on like building security into your workflow. So making sure that every code that you ship to your customers has been through thorough scans of both for the dependencies of your project, but also for your source code itself.
Awesome, great.
And I should give actually a thumbs up to your T-shirt.
Thank you.
Awesome. Okay. Well, I think that was the warm up. Bas, are you ready to present?
Yeah, let me share my screen here, and then I'm ready to go. Let me just share.
Excellent, excellent. So today we're streaming on both Twitch and YouTube, and see we have a good number of participants on both platforms this morning, so that's great.
So can you see my browser window with the Code to Cloud with GitHub presentation?
Yes.
Yeah, let me bring it up for. Great. And if you go into presentation mode,
yeah, I'll just present this way because I will switch between tabs on my browser, so it makes it easier for me to also share. So I think it's I want to just be really practical in this talk, focusing on demonstrating some of the features rather than just only using slides to talk about stuff.
Fantastic.
Awesome, great. Well, no further introduction, I think. Thanks for joining. The stage is all yours, Bas, and we will see you.
Thank you. Yeah, thanks everyone for joining this talk, and also of course thanks to Rasmus and Sherry for inviting me to present the Code to Cloud with GitHub to you. As already said, I will focus more on the security part. So I want to give you an overview of the security features, so how you can build security into your developer workflows. For those of you who are less familiar with the GitHub platform, so GitHub is, you could say the largest developer community. I think most of you, if you're doing some software development, you might be familiar with GitHub for its open source projects. Most open source in the world is maintained on the GitHub platform. And so if you're using GitHub also to build your software internally, there's a lot of benefits to this of having, being backed, you could say, by a platform that hosts most open source. Because the way we build software nowadays is on top of open source foundations, right? I think the majority of the code that you ship to your customers nowadays is like, is like open source rather than code developed often by your own core teams. And so GitHub provides an end-to-end workflow for your software development. So on the client side, we provide GitHub Desktop. We have a GitHub CLI, so a command line interface that you can use. Of course, GitHub is built on top of the Git version control system. We integrate with IDEs. And so there's plenty of tools that you can use just to build, to make code changes and then push them to the GitHub platform. On the other end, so GitHub can be deployed to any cloud or to your own infrastructure. So we provide our own continuous integration, continuous delivery. But at the same time, I think it's important, GitHub is also a very open platform. So we have well-maintained and feature-complete like APIs, both REST APIs, GraphQL APIs that you can use. We have GitHub apps, so we have a whole infrastructure, like an ecosystem allowing you to build your own integrations with GitHub. And for us, that has always been really key. If you want to bring your own integrations, if you want to use a different continuous integration system, like maybe you've invested heavily in Jenkins or using Azure pipelines, you can just bring them to GitHub and use and just trigger jobs from GitHub. And then the CI system will also provide you with feedback on a summary page, on the checks page. So we want to give you flexibility. I think it's for GitHub, it's always been our goal to help developers to be productive. And we all know developers are highly opinionated people. So we want to give you the ability also to, want to provide a feature complete platform, but at the same time, provide you with a way of bringing, the tools that you prefer that make you more productive as a developer. If we look at the main areas, you could say like the pillars of GitHub, then we're investing heavily in the kind of 4 key product areas. And I will focus a bit on the security and compliance part today. Another one really is the code to cloud DevOps. So we're heavily investing currently in continuous integration, continuous delivery with GitHub Actions, GitHub Packages, GitHub Container Registry, for example. And then, of course, one of the the pillars that has been foundational to GitHub right from the start is, of course, team collaboration. So GitHub was founded to make open source contributions easier, even though right from the start, when GitHub started around 2008, we already had the ability to have private repositories right from the start. We had like customers that were actually also like paying for the services, because a lot of people have always asked me like, how does GitHub make money? Because you can just use GitHub for free. You don't have to pay anything in order to get started as a developer. And then another area that is really key to us is like developer talent. So we're investing a lot in education. So having features like GitHub Classroom, for example, so providing universities and other encoding schools with a platform that students can use and that teachers can use to do, like, for example, do assessments and things like that on the GitHub platform. And then everything that we do is with the community in mind. So the features that we built, we always think about how can we also kind of enable and also empower the community, and how can we build features that the community can easily contribute to make things better. I mean, we're all developers, we're all able to sort of build stuff and help improve things. And that is for us also a really important part. At the foundation of GitHub, there is the GitHub workflow, you could say. So it's also known as the pull request workflow. So the pull request workflow you could say was one of the major, you could say, inventions done by GitHubs to make it easier for open source communities to make contributions to open source projects. So without having write permissions, so you could kind of fork a project and then open a pull request. So like, propose code changes back to the core team. Nowadays, of course, in open source, you would still, fork a project. So you make like a copy because you do not have write permissions to the upstream project. But if you build software internally, of course, in most cases as a developer, you will have write permissions on the projects that you are a core contributor to. So there's no need to work with a fork. But even internally, if you build like a culture of what we call like inner source, so if you try to build like a developer community internal to your organization where people can contribute to each other's projects. For example, one team might maintain an infrastructure as code project, so like Terraform modules, for example, that you're also using, and then in some cases you might still have only read access, so you will contribute through by creating a fork. So the GitHub workflow really is like, what is key is it's a branch-based workflow. So typically you have like a main branch that contains the source code that you have in production. And from there, you create a feature branch, and then you start making some code changes. Often you start with a few commits locally, and then you push your changes to GitHub and open a pull request. And the idea behind the pull request is really sort of that is a place where you tell others what you're working on and where you can collect feedback from your peers. That could be like pretty open feedback, so opening up for people to just bring you advice. But very often, of course, if you're building software, you have a more like secure workflow, you could say, where you have like a formal review process, where you will request a review from your peers. It could also be people that have specific responsibilities within the team. So if you have a mono repo with a front end and a back end, for example, then the front end team might be different from the back end team. So there might be different people that are entitled for review, which is something you can control using a code owners file. And then after approvals, that can also be required. So you could sort of enforce approvals. You might want to validate your source code. Of course, when you use continuous integration, there's a continuous sort of feedback that you get from your CI server. And after validation, you can merge your changes in the main branch. Now, this part of the workflow, there's a lot of different ways of how customers do it. A continuous delivery workflow, for example, might look different. There you might continuously sort of build small features and merge them into the main branch or ship them to your customers. If you have distributed software, you might have a bunch of other like more long-living branches for specific releases, because sometimes you might have to do like a patch release for some older release if there's some security or some bug detected in an older version that you need to fix. So those workflows might be slightly more complicated in terms of branch management. I just want to briefly just illustrate how we deploy at GitHub. So GitHub can be, there's GitHub.com, which is like the SaaS solution that a lot of our customers use. But GitHub is also, we also ship it as an appliance. So you can run GitHub on premise if you want, on your own infrastructure or in the cloud infrastructure that you control. But our continuous deployment model is slightly different from what a lot of our customers are using, because what we do is, where we have this squirrel just saying validate, that is where we actually deploy into production. So what we typically do is when features are developed, we used to have like a queue where developers would wait until it was their turn to ship a small feature into a production environment. Nowadays, we have like what we call not deploy queues, but we have merge queues. So a bunch of features that are, individual pull requests, they get merged into a single pull request that contains a bunch of features that we can ship in one go. And typically what we do is from that particular merge request branch, we will deploy into production in a bunch of stages. So we start with a very small canary. So this is all like controlled by Kubernetes pods. Where we will just deploy to a small percentage of requests to test and validate the changes. And then we will just grow into a 20%. And then from there, if everything looks fine, so there's not an increase in exceptions, for example, not a decrease in performance, then we can deploy to production. And only after those changes are validated in production, that's when we merge those changes into the main branch. And this way, what we can do is we can ensure that the main branch is always stable. So we can always roll back. If something goes wrong in this, we can always quickly roll back to the main branch. So that is how we deploy at GitHub. So hopefully it's one day in the future, we might be able to ship these kind of merge queues as a feature on GitHub. Today, it's something we've built internally, but it's also something that a lot of our customers request. And today you would rely on third-party integrations in order to get those features. I want to share a few sort of best practices, because what we see a lot with customers is that they open a pull request really late in the development process. So typically a developer would just work on some new feature, and when they think it's done, so when it's ready for review, then they open a pull request. And one thing that we always recommend our customers to do is open a pull request as early as possible, because then you can collect early feedback. And also the features that we built that I'll be talking about in a second. Also, so they like security, for example. I mean, the earlier you get feedback on your code changes, the better. I'll skip the other best practices for now, and we'll move on, because I want to be able to spend some time on this, showing you some of the features. So, like I shared before, nowadays we build our software on top of open source, and I think about maybe 80 to 90% of projects. So if you create a new project nowadays, you would typically bring in some open source foundations and you build on top of those. So the lines of code that you ship, include a lot of open source code that is not maintained by your core teams, but maintained by the open source community. At the same time, what we recognized is that a lot of vulnerabilities in third-party libraries, so in open source libraries, of course, they are fixed, but very often they did not get like a CVE identifier. And without a CVE identifier, those fixes will not end up in databases, that contain in vulnerability databases. And so once GitHub recognizes that, we started investing in an end-to-end workflow. I'll go through this really quickly. But this, you could say, is like, for us, it's like an innovation similar to the pull request workflow. It's like providing a secure workflow in, helping open source maintainers to keep their code secure. And this starts with security researches that, we help to sort of identify vulnerabilities in source code. We provide the community, we provide them with tools in order to detect vulnerabilities in source code. And then we've built a workflow on GitHub where they can open a draft advisory to the maintainers of a project when they detect some vulnerability. And then the maintainer can create like a private fork. So even in a public repository, they can create a private fork where they can fix the vulnerability. They can update the advisory with the information about, this version has a vulnerability and this is the patched version that provides a fix. And then they can also request a CV identifier from GitHub, because a lot of open source maintainers are not aware of the CVE workflow. So we built that into the GitHub platform. So we are an authorized CVE numbering authority. And so we can provide a CVE identifier, we can review the fix, and then we publish the advisory in our own advisory database on GitHub. So we maintain our own advisory database, where we bring in a lot of other sources, of course, because there's many places in the world where fixes are recorded. So we bring in the National Vulnerability Database, the PHP community and NPM have their own vulnerability databases, and we also bring those in. But there's more and more advisories that are created on GitHub itself. And then, of course, we can alert you as a developer that there's a vulnerability in the dependency, and we help you to fix it. I'll talk about that in a sec. So one of the goals here really is to sort of do this sort of shift left. I know a lot of people are talking about shift left nowadays, so people get tired of the, at some point, some terminology becomes kind of hollow. But the idea here is, we integrate all these features into the pull request workflow, because that is typically where, when you push changes, we want to give you early feedback on the quality of your code, similar to how you use continuous integration on every push, that provides you with feedback around your test coverage, for example. And so the features that we provide around security in the workflow is security alerts, so a graph of your dependencies. And then we can notify you if there is a vulnerability in any of your dependencies. And this way, we make it easier for you to fix any vulnerabilities in dependencies. But on top of that, we can also automatically open a pull request for you. So we have a bot on GitHub called DependaBot. And DependaBot can open a pull request with a suggested fix to make it easier for you to fix a vulnerability. Often it's quite easy, just a version bump, because the fix is in a third-party library. So updating the version will often to a patched version will resolve it. But again, it's easier if there's already like an open pull request with a suggested fix, rather than you as a developer having to figure out exactly how to what needs to be updated in your manifest files. But we can go beyond this. Not all fixes have a CV identifier, so it's always a good practice to keep your your third-party libraries up to date, and that is also something that you can do with DependaBot. So you can configure DependaBot to help you to keep your libraries, third-party libraries, up to date, Docker images that you might use, third-party GitHub Actions, Terraform modules. So these kind of things you can all configure for DependaBot to help you to keep up to date. And then something we shipped, I think even yesterday, is like you can now also configure private package registry. So if you're using Artifactory, for example, you can also configure that as endpoint for your dependencies. And then one other feature that is currently in beta is dependency reviews. And that is, you will receive an annotation. So in your pull request, if you add, as part of your change set in the pull request, if you add a third-party library that has a vulnerability, so then we immediately report it to you in the pull request, so to allow even faster remediation. So far, we've been talking about third-party libraries. And then there's, of course, also on top of the open source, you still build source code, right? So as a developer, otherwise we wouldn't have a job. So we build our own source code, and for that we provide a static code analysis solution on GitHub called we call it code scanning. It's based on a query language called CodeQL. So what we do is we sort of codify, you could say, we sort of create a snapshot, database snapshot of your repository at a certain point, and then we can scan it using a query pack. So a pack of queries written using CodeQL. So it's literally a query language like you have SQL, for example, where you can codify vulnerabilities. And this is powered by the community, so by the security researchers of large companies like Microsoft, for example, and Google and Uber. They have the luxury of hiring security researchers, And so together, of course, also with the security researchers at GitHub, we codify vulnerabilities and add them to a open source repository where all these queries are collected. And from there, we build query packs that you can run against your code for the programming languages that you use. So you can also use CodeQL as a research tool. So if you want, you can write queries. So you can create a database, so like a snapshot out of your code base, and then also use that in order to research on your source code. Code scanning is powered by GitHub Actions. So it's also using, so GitHub Actions is GitHub's CI/CD solution. Again, it's community driven. There's many third-party actions, like thousands of third-party actions around that you can bring into your workflows. We support any operating system. I think one of the most powerful features of GitHub Actions really is that it supports all the webhooks. So you can not only trigger an action using a push event or a pull request event, but you can use any event supported by webhooks on GitHub in order to build a trigger into your action. And you can also have manual triggers. You can have even extra applications triggering a workflow. So that provides a very flexible framework that allows you to sort of automate any part of your workflow. So not just a push event, but also when someone, I don't know, creates an issue or a pull request, creates a release, tags a release, creates a package on GitHub. So all these events are supported as triggers for your CI/CD kind of workflows. Then we have package support on GitHub also. And we have a container registry, so allowing you to also host containers, and you can also provide like, fine-grained permission sets on those containers, so that just like allow other projects to have access, or we even support anonymous access if you need. So with this, I want to quickly jump into a short demo showing you some of the features. So this is just a project on GitHub. And so if we go to the settings and security analysis, here we can configure what feature we want to use. So we're using the dependency graph. So that is like a visualization of the dependencies in my project. Then we have configured Dependabot, and we also have configured here GitHub Advanced Security. That is the offering. So it's an add-on offering for private repositories. It's free for open source, where we provide code scanning, and also we provide secret scanning. So if it's like detecting any hard-coded secrets in your source code. And so if I jump to security here and I go to the Dependabot alerts, you can see that there's one vulnerability in a dependency. It's not a very critical one. It's a vulnerability in JUnit, which is like the testing framework. This is a Java project. And so the recommended path in order to resolve this vulnerability, the vulnerability is in 4.13. So the resolution, the patch release is 4.13.1. And I can follow up these instructions here as a developer to fix it. But it's, of course, easier to just have a pull request open for you. Let me try to find it. This one should be closed because I will explain that in a second. So this was the original pull request that was opened by Dependabot when it detected the vulnerability in 4.13. It provides a compatibility score, so it will tell me how likely is it that there are breaking changes in this change set. So it's not very likely. We're pretty close to 100%. The one detail that you see here is typically this would be an open pull request that you will fix, but in the meantime, there's also been a new update on JUnit. So there's a 4.13.2 out, which is just a pull request for an update. And you can see that, Dependabot is pretty, I wouldn't say intelligent, but there's rules built into Dependabot that it can just close out the old one, because this one just supersedes the other one, because it's recommended to just not go from 4.13 first to 4.13.1, but go straight to 4.13.2. That fixes our vulnerability, and it might also include some other fixes that can help us to keep our code secure. And you can see a few others here. There are some other suggestions for just updates, but you can also hear there's a few GitHub Actions related ones. And from here, I want to quickly jump into the code scanning part. So we have our code scanning. We have a pull request open here, and we have a code scanning status that is red, so it's not passing. And so if we go to the details here, we can see here that we have introduced a vulnerability in our source code. This is a SQL injection vulnerability. I can look at the path, so I can just see how the data related to this vulnerability travels from source to sink in my application. And what I'm doing here is I'm just literally sort of concatenating a value that is entered by the end user in the user interface in my query, and that is not really a good practice. I should have used a prepared statement here. And so on, this code scanning alert helps me to just fix this. I can also see this same sort of annotation in my change set. So if I'm doing code review and I'm going through the diff files, then I can also see here that there is this particular alert. In some cases, as a developer, I might easily sort of be able to fix this myself. I might immediately say, I should have used a prepared statement here. But in other cases, I might be less familiar with the vulnerability. So then I can go to more details, and that brings me into the security tab. And then there is a whole article dedicated to explaining to me what is the vulnerability about for my in this case, Java, and providing me with examples. So we can see the concatenated value here. So that is a bad example. And we can see a prepared statement used here, which is a good example. So that resolves this particular vulnerability. There's also links. So if I'm a developer and I'm less familiar with prepared statements, I can learn more by just going through, following the links here to the tutorials. If I want to learn what is the source of this class of vulnerabilities, I can go to the OWASP, because SQL injections are an OWASP type of vulnerability. So you can see here that we provide all the context as a developer that you need in order to fix this vulnerability in your source code. We want to help you to understand the vulnerability and how to fix it as early as possible in the developer process. As soon as you push changes to GitHub, we will sort of report these to you, and we will provide you with the context to help you to sort of fix this vulnerability as soon as possible in your source code. And you can also tie these statuses to branch protection rules, so you can harden your workflows and say, hey, as long as there is issues, so as long as we have a status red for code scanning, you cannot merge any changes to the main branch of your project. So that is one of the additional sort of things you can do in order to harden your workflows. So it's almost time, so I will quickly sort of wrap up. So what we've looked at is the dependency graph on GitHub. So we built a graph of the dependencies for your project, so all the third-party libraries that you're using. And we can alert you if there's any vulnerabilities known in any of your dependencies by sourcing it from our advisory database that brings in many resources across in order to provide an as complete picture as possible around the health of your third-party libraries. And then we have these security alerts helping you to fix these vulnerabilities. We provide you with updates, so Dependabot can help you also to keep dependencies up to date. I briefly mentioned the dependency review that can, even detect any issues with third-party libraries even earlier in the development process. So while you still have a pull request open, so as soon as you introduce that third-party library to your source code. We haven't talked about secret scanning here because due to a lack of time, but we can also scan for hard-coded secrets, and they will also appear. So you will get an alert for those, and they are also listed in the security tab. We briefly, talked about code scanning capabilities on GitHub, and then to harden your workflows, you can use branch protection rules, and you can also use commit signing. And the final remark I want to make is that we're also working on providing a security overview, so both on the organization level, on team level, and so providing you with a dashboard that brings all these security features together in a single overview, so that you can, just by visiting on GitHub or across the repositories that you own as a team. And so with this, I just want to close out because my time's up. Thank you so much for joining, and I hope you enjoy the rest of the conference.
Awesome. Hey, we need an applause.
Yeah. Oh,
you have to settle for us, Baz. I'm sure everyone at home is doing the same stuff. Thank you so much for the presentation. Really interesting. And there was a bit of a cliffhanger there at the end on focusing on more of the security scanning stuff. So maybe we need to invite you back
definitely
at a later point so we can go deeper in that.
Yeah.
I'm happy to come back anytime. Yeah, in half an hour, I had to go fast because there was so much I just wanted to go through. But yeah, I'd be happy to spend more time with you and talking in more detail about these features.
Excellent,
Fantastic.
excellent. Well, for sure, people are commenting positive. You can see it on your screen here.
Yes.
Oh.
And then to the audience out there, please type the question for Bas in the chat, and we are going to bring it and highlight it for him during the panel discussion, and he's going to answer them all there.
Yep, I'll be back at 11.
Yes.
Okay, see you later.
See you
Yeah,
later.
thank you.
Thanks for having me. Thanks.
Thanks. So now it's the time for the next speaker.
Absolutely. So, and one I know very well, actually. So the next speaker actually comes from Maersk.
Yes.
And let's just bring Vakas in here. Morning, Vakas.
Good morning,
Hello.
Maka.
Good
I know.
morning.
Thanks for joining us. We just heard from GitHub a really interesting talk there and about automated testing and into scanning, etc. But we're all looking forward to hear about infrastructure as code now.
Yes.
Good.
So for those of you that don't know Vakas, so Vakas is working as a software engineer at Maersk. Maybe Vakas, you can tell us a little bit that what do you do there as a software engineer? What are your daily tasks?
Yeah, sure. So I work in Maersk as a software engineer, and I'm also the technical lead on one of the projects. And every day I write code for which runs in the cloud, primarily in Azure. And a lot of code, a lot of pull request reviews, a lot of testing. So I myself like to test stuff a lot. So and I urge people to write tests for their code. So that's what I look for when I'm looking for in the pull requests. So yeah, I'm writing mostly code all day and reviewing other people's code, designing applications. That's my typical day in Maersk.
Fantastic. And you're also giving talks because you've been at Dev Show 2 times, not only 1 time.
Yes.
So
Yes.
I'm really happy that I keep seeing you more and more in the community.
Yeah, it was pretty good last time, twice actually, and yeah, I would like to peek my head out whenever I can. I kind of like that. Yeah.
That's good. I'm pretty sure both Dev Show and also Azure user group and DevOps user group, they always want you to have a speaker.
Absolutely. No, Vakas, thanks for joining today. So Vakas and I are colleagues normally, but today we're just in the community, right? And actually, as one of the changes I really appreciate working for an enterprise like Maersk is the openness and the willingness to share learnings.
Yeah.
It's something I advocate for because you know what, we're not competitors here. We're actually here to all make a better world, right? And
Exactly.
we do that through software. So I really appreciate you taking time out of your working day, Vakas, and spending here with us today.
Thanks for having me.
And the session today is about infrastructure as code, something we introduced in Maersk, a handful of years ago. Programmatically, probably about 4 years ago, and ever since Vakas joined, he's been key in developing this, I'll say, fundamental DevOps practice, which is about, reusing code, right? It's about leveraging the fact that you're an enterprise, and once you've written a deployment, you can use that again and again and again. And that's really a strength of being a big organization, and a hot topic here. So with that, I think we're ready to go, Vakas, if you are.
Yes,
would you mind
sure.
sharing your screen? And for everyone there, I hope you caught the first secret. The first secret word. Vakas will have a secret as well, maybe.
Yes. Write it down. We will need it later.
Nobody
Right.
knows, right?
So with that, Vakas, the stage is all yours. Go ahead.
All right, thank you. So today's talk is revolving around infrastructure as code, and you already know who I am. I am actually working with all of the things that you will see now, and that's my day-to-day in Mask. So let's get started. First, let me give you a quick um, introduction to the old days, not so good old days, where you had some. If you have a web app, and I remember doing it, if I wanted to install it on a server, I would go ahead and do some manual configuration. There was some database stuff that I had to take care of, and some other things, unknown things, networking. And then my app had to wait for deployment. There was a lot of manual stuff going on in those not so good old days. And then imagine that when you were successful in doing those things in that time, then whenever there was a new release or you have to upgrade an application, you have to go there and do it manually again. And then the whole process was very slow, and it took a lot of effort and a lot of resources in terms of humans at that time. And there was a higher chance that you could make an error, because whenever we humans are involved in these kind of processes, there is a higher chance that we can make some errors. And if we talk about disaster recovery for those things, it was there, but it was slow. And imagine that if someone told you at that time that, okay, now you have the development environment running, now you have to make the production environment, it would take you the same amount of time that you take for the development environment. And if you add more environments, then you add the same amount of time. So all of this was very time consuming. And all of this actually can be addressed and is addressed by something we call infrastructure as code. And infrastructure as code is something that it's the same thing that we used to do before, but now it's in terms of code. So it's the management of your infrastructure in a descriptive model. So it's the key DevOps. It's now has become a key DevOps practice, and it's used in conjunction with the continuous delivery that you do. So in what happens in infrastructure as code is that you have all of your infrastructure written in form of code, and then you deal it the same way as you deal the code. So imagine that you have your data center written down on paper, or in a virtual paper, I would say. You have servers, you have web apps, you have networks, even maybe if it's Azure related, Azure functions. Everything can be written down in form of code and can be deployed into multiple environments. So let's take a look at some of the benefits that infrastructure as code brings to the table. So infrastructure as code, it's, as I said, it's a blueprint of your infrastructure, and it brings you faster and reliable deployments. So once you create one environment, you can replicate that across multiple environments, and you know that it's exactly the same environment that you're running. So it's easier for testing, and you know you have full control on what goes out into your different environments. It's highly scalable at the same time. So imagine if you are deploying some virtual machines, let's say, or some web apps in development environment. So you can make a few changes in your code, and then within a few minutes you can have as many instances as you want. Some of the more benefits of infrastructure as code is that it's idempotent. That means that whenever you deploy it, it gives you the same results every time. So the configuration doesn't change if you don't change the variables around it. Since it's code, so it can be version controlled. So now your whole infrastructure has a version, and that's pretty powerful. And I'll show you a practical implementation of all this later on. And then, since it's all written down in code, the disaster recovery is very easy and very fast. So if something goes bad, you run a couple of commands, and then you're back in a matter of minutes or in a matter of hours, depending on how big your infrastructure is. And since we all are programmers, so I love to test my code. This is also very testable. You can write tests around the code, and you can deploy it in an automated way as well. You can use pipelines to deploy your infrastructure. You can deploy almost everything through pipelines, and I will show you some of the examples of that later on. But just keep this in mind, that the infrastructure as code is a concept, and there are multiple tools. We're going to talk about different tools that apply those concepts. First, let's take a look at some of the two approaches that belong to the infrastructure as code. So there's a declarative approach. So actually, declarative and imperative, these are two different programming paradigms. And infrastructure as code is also using those. So one is declarative, which is more functional, and it's you just take what you want and you don't care how it's done. And imperative is actually procedural, so you have different steps, and you can see those steps. So here's a C# example of something that you are looking for. Here you just add this where, and this where actually takes care of this logic. But if I would look at the imperative, this is something that is written step by step. Why I'm telling you this is because the tool that we chose is using a declarative paradigm. And why it's doing that, I'm gonna tell you in a minute. So now we have the infrastructure as code as an introduction. There are some best practices that you need to keep in mind when you're doing infrastructure as code. So the code should always be your single source of truth in terms when you're deploying your infrastructure, you're saving your infrastructure in code. It should be version controlled. You can put it in version control software like Git, and then you can version control it. And the code itself is the documentation for your infrastructure. So you don't have to keep a separate set of documentation. You might do in some cases, but the code itself tells you what it's doing. And since it's in some kind of a version control software, it's a central repository that is keeping all of your stuff. And also, it's a best practice to test your code, spend time on automating the tests. And whenever you are making some infrastructure as code building blocks, they should be reviewed by your peers, other people. So these are some of the best practices, and I will show you how they come into practice at Mask. So now let's take a look at some of the tools that infrastructure as code paradigm provides. So we have different tools. We have Terraform, Ansible, Puppet. There's a new guy in town, Bicep, Chef. So these are the tools that let you do infrastructure as code. And all of them have their own way of doing it. But at Mask, we decided to go with Terraform. And a couple of years back, we did this comparison between different tools, and one of the reasons that we chose Terraform is because it's using this declarative way of writing code. So it's a simple, human readable way. If you look at the code of written in this language, it's the language is by the corporation. There's a HashiCorp. It's called the HashiCorp language, and it's pretty straightforward. It's easier to read, so there's a less learning curve there. And it's open source, and it gives you the possibility to have this immutable infrastructure. And Terraform provides you. It has these 3 basic commands. So it tells you to write your building block, and then run the plan command, and then apply it. So first you write it. So here you can see this is a simple block of code written by someone from Terraform. You can find it online on their website. And once you write it, you make a plan, and you write this command Terraform plan, and it gives you the future state with how it's going to look like if you go ahead and deploy this. And then the last step is to apply, is to take this plan and make it happen in real life. I will show you later on how this is done practically. So let's look at some of the concepts that Terraform has. The first concept I would like you to get familiar with is resources. The resources are the main building blocks, or the infrastructure objects in infrastructure as code. So in Terraform world, resource group. So here we have a resource group, resource, and these resources are provided by some kind of a provider. So it could be Azure, AWS. You can find tons of provider on Terraform website. And the other very important concept is modules. And what these modules are is it's actually a container of different resources put together. And these modules give you this reusable blueprint for your infrastructure. So you can write your resources, combine them together, and then it becomes your blueprint for your infrastructure. Then you can reuse it. You can add more resources. You can remove some resources, or you can add more modules. There could be a module could be consisting of multiple modules put together, and then you can share them. You can reuse them across wherever you want. So this module concept is it's very powerful in Terraform, and the reusability part and sharing part, and then you can go ahead and test that module with some of the tools that are also you can find open source. And so the module structure, if you look at that inside the module, you have some resources inside, and then you have some inputs, and you have some outputs. So in technical terms, these are input variables that require some kind of input from the user. So you have to provide some kind of values to them, and you might have or might not have some outputs. So this is what a module is. But now let's take a look at what we did in Mask and take all of this together. So we had Terraform. We wanted to do infrastructure as code, and we wanted to make some unified approach to infrastructure automation across the enterprise. And what we did is we established some common practices. We established a framework, a set of self-service tools that would help everybody to contribute and consume those building blocks. And we helped to define these building blocks in a way that they were secure. There was some governance around it, and we also provide documentation on deploying and sharing and reusing all these infrastructures. I'm gonna show you how it's done in a minute. So when we talk about this infrastructure as code in Mask terms, I would like to there are these three very important things that I would like you to get familiar with. So one of the top things that we have in mind, or we still have it in mind, was delivery time. So what we did is it offers a high degree of self-service. So you can just go ahead and pick and choose and get up and running very fast. And since they're reusable, so whatever you have wrote or someone else has wrote, you can use it. Or if you wrote something, someone else can also use it. And we kind of encapsulated all the complexity. So the end user doesn't need to care about how it's implemented. They can just go ahead and start using the building blocks. The second very important thing is the governance around it. So we made some frameworks to test all of this. We created some automated tests, and There is also an aspect, a huge aspect of security is involved around it, and we promote immutability because it's version controlled. So whenever you make a change, you have to upgrade the version. So it uses this semantic versioning. So whenever someone makes a new contribution, it goes through a set of processes and the version is changed. So the previous version is not touched. You have to make an update and make a new version. And then the most important is the business continuity. So if something goes wrong, how fast can we get back up and running? And since infrastructure as code has disaster recovery built into it, so we are using it to the highest extent possible. So business continuity is very important part of all this. So another important concept that it's not Terraform related, it's called a stack. And what a stack is actually is it's multiple modules joined together. So think of it as if you think about an e-commerce app, a web app, you have a web app, an app service plan, an Azure function, blob storage inside, and then we give it a name. We call it let's call it an e-commerce app. Now it's a stack, and why we did it is because now we can make this stack and then deploy it into the actual and into the real world. It's the same concept. It's you can think of it as a very big module, which has a lot of other modules inside. So if you remember the modules, the Terraform modules discussion we had, so we took the same modules, we created a framework around it. We added some documentation to the modules. We added some tests to those modules, and we added some other building blocks. So if a contributor comes in and they want to create a module, it gets very easy for them to get up and running as fast as possible. So now we know the concept of module stack. Now I will talk about how all of this comes together. So the very central piece we have is the Mask infrastructure registry, which contains all the modules that we have. So this is the same concept as you have the registry Terraform provides. They have all the modules and living inside. We have our own registry where we put all the modules, and now I will show you how this the discussion we had before, how this is put into practice here. So there are two main actors that are involved in all this. So one is the contributors, the guys who are the people who are creating these building blocks, and the consumers who are going to use them. So we had this registry. We created some APIs around it, so it would give you all the basic list and get functions. You could download modules from there, and then on top of that, we created some runtime, and all of this is actually inside of our cloud management tool. And this runtime is actually the state we are providing. We are using Terraform, so we are using Terraform state, and we are providing state as a service to our consumers. They can use that runtime and they can go ahead and deploy stuff. And then we added more automation on top of it, which means that we provided some pipeline as code, some templates for the contributors to get started as quickly as possible with whatever change they want to make. And then once the runtime is ready, then we added some processes around it. So and these processes means that everything is documented, and it's actually based on the inner source contribution model. So anybody in Mask can come in and contribute to their registry, and anybody can consume it. So the processes actually is what tells you that how you can get started if you want to go ahead and become a contributor, or how you can become a consumer, what steps you need to do. So whenever a contributor is doing some contributions, it goes through a series of steps. We will take a look at them in the next slide. It goes through a series of steps, and then once those steps are done, then your module makes its way to the registry. So now we have this. Now we know what infrastructure as code is. Now we know what modules are and what stacks are, and what's the infrastructure registry is. Now I'll show you the practical implementation of this. So we are familiar with the infrastructure registry part, where we have the runtime, we have some processes, we have some APIs that access the registry. So now when the contributor says, okay, they want to contribute something to the registry, they would just go ahead and collaborate with our engineers at the same time. And there will be an ongoing discussion about what kind of module, or there could also be possible that the contributor and the engineer could be the same guy. It could be multiple guys. And then at the same time, they're talking to the security team, and security team is looking into whatever they're building, if it's secure enough, if it's using the right things, and in terms of, because it's code, so it's easier for them to collaborate. And then at this very same time, the contributor is looking into our cloud principles, and the end product is actually secure by design. And once this product is ready, you create a pull request against our infrastructure registry. And here on this step, we would run some automated tests, some peer reviews, and if everything goes fine, then you make your way into the registry. Once it's in the registry, you can consume it. So there is a bunch of documentation already, the part of the processes for the consumers, and the consumers just take and start using it. So whatever you pick from the registry, you are sure that this is secure, and this is the right. So you can the right piece of building block. So you can just go ahead and start using it, because everything else is taken care of. You just pick and choose, and whatever you want to use. So if it makes its way into the registry, that means you can go ahead and use it. So there's there are multiple implementations of all this. I'm going to show you only one of that, because there's not enough time to show you all of them. So all of this is actually boiled down to, let me go to Chrome here. And yeah, so I have, just to save time, I have already opened up our tool called Composer. And this is one of, so that's how the whole discussion we had manifested itself in form of Composer and some other tools around it. And so this is one way. So if you want to use the UI, that's our low code, no code tool that you can use to create your infrastructure. There are other ways to do it also. If you are code savvy, you can also do that. I'm not going to talk about that here. So this is our cloud management tool. So the rest of the stuff here is irrelevant for the talk here. So let's look at this one. So in Composer, actually, you can create all of the stacks that we were talking about. And what you see here is these are the modules. So you can add modules from the list here. So this is the reading from this list is coming from the registry, and you have multiple modules coming in. You can pick and choose whatever module you want to use, and then you can combine them. You can combine them, and you can start to use them here into the canvas. So once it's here, then you can if you remember, I talked about some input and output variables. So um, these are the inputs and these are the outputs, and then you can decide, okay, what goes into the module, what goes out of the module, and if you need something out, you can create new variables here. You can add variables, and that's where you can create your infrastructure like that. And it can get very complicated because it depends on your needs. So this whole canvas can be filled up with different building blocks. So I'm not gonna add all of the modules here, but just to give you an idea of how this is done. And then once you're happy, you can take a look at the code. So it generates the code in JSON for you, and you can see right now I have only added these 3 modules here, and it just tells you if there is input or output in forms of code. You can go ahead and download it, and you can go ahead and use this code to do a manual deployment if you want to. But we not only stop here, it's also versioned. So this stack, whenever we save it, it's also versioned. So once you're ready with your stack, you can go and you can actually go to another screen here. I have already, to save time, I've just prepared the screen for you guys already. So you end up, so we were here in Composer, you end up in the services, and I created this service. That's a service is actually an implementation of the stack. And then you select your environment, and in that environment, this green check mark tells me that I have already deployed something using previously, using whatever I created in the Composer. So now here this blade tells me that, okay, now I have to configure some of the stuff that I created earlier. So I will create some, I will add some values to the input variables, and I can even, so there's some connections and repositories that you have to choose. That's specific to us only. And what interesting thing is here is that you can ask it to create a pull request for you, and you can also add this to run a Terraform plan automatically. So when you create the pull request, it will also run the plan. If you remember earlier, I showed you the write, plan, and apply phases. So it will run the plan on the pull request. So you would know when your code is being reviewed that what output it will bring. And then you can choose the version of the Terraform here. And once you click publish, I am not going to do that. I've already published that earlier. It creates a pull request for you. And then this pull request is reviewed, and something, once it's merged, then you can go to the next phase, which is the plan and apply phase. And then you can see that I have the plan phase automatically. So when the pull request is merged in, the plan phase automatically runs, and then the apply phase is the next one, which is the actual deployment. So this is happening automatically, and there is no human intervention involved, unless if you decide to do so. Before applying, you can add some gates here. So, and then you will have some resources in Azure in the end. So that's one of the ways that we have created. So all of the discussion we had before, that manifested itself in form of this whole piece of infrastructure that we saw, the Composer and some service and some deployments. So that was only one way that I showed you how to create this. There's another way that for the code people who just would like to do all this in code. So what actually we did is we took the best practices in infrastructure as code, and we just make them in real time. So we reduced the infrastructure time to infrastructure significantly by doing that. All of this is governed, and there's a bunch of governance revolving around it. And the reusability part is increased, because if we have a bunch of modules that can be reused as many times as you want, and we know it's secure, we know it's reliable, and it's pretty simplifies. So if I don't know how to create or contribute to the module, I just want my web app to run into the cloud, I will just create a stack, put in a bunch of things that I want, maybe a function app or app service plan, something, and then I will just deploy it. And then I don't care. I don't have to code it, and I can get up and running in a matter of minutes. And if something goes bad, you have seen the services page, you can go back, click, and republish it again, and then it publishes your stuff again into the cloud. So disaster recovery is very fast in all this as well. With that said, I'm almost out of time. I can see that. So thank you so much. That's all from me. You can find me on these channels. And if you have any questions about today's talk, or if you have any updates, you can please get in touch. Back to you guys.
Thank you very much, Marcus. That was indeed a really insightful talk about all the cool stuff that you do at Maersk. Thank you for sharing that with us. And to all of you out there, if you have question for Vakas, please type it in the chat. We are going to highlight it for him. And of course, you got a lot of good feedback here from the audience, as well as what you see that Thomas also and Richard, Peter. You can go on the chat on YouTube and then read all the good stuff for you. So thank you very much for being with us, and we are going to have you back again during our panel. So right now we have a little bit of a break. For how long actually, Rasmus?
6 minutes.
6 minutes. Okay. So 6-minute break till we have our next speaker. And now I guess it's time for having some giveaway. Let me share my screen. As I mentioned you, we are going to have yes. Okay. I assume my screen is shared too, because I cannot see it here. Okay, thank you. Okay, so for all of you out there, you are learning more and more about Azure today. And as a thank you from Microsoft, we are giving you this learner badge, which is a token of appreciation from us to all of you. But this time, as I mentioned, that the learner badge has a secret. The first 10 people that scan this QR code, you will have, let me go to the next slide. Yes. Once you get it in your wallet, because one of the things is that this Azure Heroes badge, they are all NFT tokens. So which means that you need to have a digital wallet. Once you scan that, if it's the first time that you have it, you need to install an app, which is by our partner Engine, where you keep all of these badges there. And also you need to specify a password for your badge, which you are going to need it later on. Otherwise, you can't have access to this badge later on. Once you have that, you can go to your badge, and for the first 10 people, there will be a reveal button there. Once you click on that one, it will ask you to enter the password, and then you will have the code. You need to copy that code and then navigate it to the URL that I mentioned it here, empty receive, and it will ask for a code. You will add that code, and then you will fill out the form with your address and you will get a secret swag box from us too. So remember to scan this code, your password, reveal code, and go to the URL and then get your swag. And a quick intro about the Azure Heroes. We have multiple different badges there. And then I'm revealing also a secret here today, because we have our new seasons, because each year all of these badges, the graphic and everything are going to be different. So the new season is coming, I guess, next week. And where you can earn these badges for multiple different reasons. For example, if you're doing a lot of community activities, you're giving a talk, you're organizing event, you can be a community leader or a content hero. If you're contributing to open source, for example, Vakas, who's here, he is also a contributor to open source, so he has an open source badge as well. You go there, navigate through the different badges that you have. You can nominate yourself. There is a form, nominate yourself or a community friend to get these badges. And yeah, I guess that's all for me. If you want to know more about Azure Heroes, the URL is there. We have a Twitter handle when we have all of our new announcements. And you can also check out the hashtag, because you see all the other people that they are having these Azure badges, and then you can see what they're talking about it. I guess that's all for me. Rasmus?
There was a question. Can we see the link again?
Yes, that is true. You can see it. And I will also copy and paste also the link to how to get the badger, and also copy and paste this one in the chat as well. Thank you. So I'm going back to the other studio.
Yeah, we are back over here. It is almost like a professional setup today. Oh, yeah, there you are.
Yeah.
Multiple cameras here and angles,
Yes,
right? We are
oh my
really
God.
showing off our technical skills. Yeah, no, everything is normal, right? That's what we kept saying this morning.
Yeah. All is good. I'm missing my background. Have you ever seen my background, which is that doggy with the coffee and off the fire? I said, oh, it's good. Everything is there.
Everything is normal. Yeah. Yeah, I think I have a sticker from you.
Yeah, I have it actually in my bag as well. Thank you for remembering.
So, and I think you lowballed your introduction of the swag pack, because yesterday you told me what was in it.
True. Okay. In that swag box, what you will have, there is a t-shirt, there is a sweater, there are socks.
Oh, socks.
Yes.
Is it Azure socks?
To be honest, I don't remember.
That's okay. Yeah. Anything sucks.
Yes, anything sucks. So we have a cup, and there is a water bottle, and of course the stickers.
Stickers, yeah, custom stickers, right?
Yes.
All right. So I think you feel that we are surrounded by swags. We have the little guys up here.
Oh, there's also chocolate.
This chocolate, yeah.
Yes.
Yeah, cloud-shaped chocolate, or
it's the badger chocolate, actually.
Badger chocolate, of course it is. You still have a chance, of course, also to be in the secret hunt. Hopefully you collected the 2 first secrets, and Renee will have the 3rd secrets embedded in his presentation somewhere. And we are seeing good questions for the panel. You also are eligible for winning prizes with questions.
Yes.
Do
you want to reveal what they will win?
Maybe we should, right? So maybe we can just see here. There's a little guy over here. It's very sensitive, but it's so cool.
Yes.
Look at this guy.
Yes. Can I ask a question as well?
Yeah, you must.
Yes. Okay. Can I also pick my question?
Yeah, you're not gonna win, but go ahead. Give us your question. All right. With this, I think we're ready to warm up to our next presenter, and we're actually back on time.
Yes.
Time management.
Right.
That's also a skill here.
Yeah.
So let's invite Renee into the stream. Morning, Renee.
Morning.
Morning. And a warm welcome to you. So Where are you joining us from?
I'm here at our office at Xpirit in Hilversum, the Netherlands. So one day at the office again. That has been a long time. That first time in I think many weeks, months. So it's good to be at the office again, especially for this conference.
I'm also back in the office after a long time. Thanks for this event that it gave me opportunity to come to the office. René, you're working as a strategy consultant at Xpirit. Can you tell us what exactly you do?
Oh yeah, that's the question my kids ask me, and I cannot answer them. Well, I help companies to implement DevOps practices in the broadest sense of the word. And although I've worked many years at the operational side of things, like implementing pipelines and Git repos and all that stuff, I now help companies to actually implement the DevOps stuff on a more strategic level, with management and how to transform your organization, building cloud centers of competence and all that stuff around it. So a little less operational, but still hopefully with my hands in the dirt once in a while. But also on a different level, doing the good stuff.
Oh, that's great.
Awesome. And you're here to talk today to us about, well, I think one topic that's very important for me, both at work but also in the community, is reliability engineering, and what I consider, actually, in considering our industry has been here for a while, a new role or an evolution of an existing role. So where have you been working with SRE topics before?
Well, at Maersk they were doing some stuff with SRE, and of course it's something that you hear a lot. It's also used, I think, sometimes very wrongfully. People call officers SREs now, and that's definitely not what it is. It's more a DevOps role, and I think you have to be careful. Many companies are working with SREs, but they actually don't really understand what it is yet. So yeah, when I was really working with SREs, I'm not sure, maybe one or two companies, but a lot of companies that are actually want to do something with SREs, but still investigating what it actually is.
Yeah, that's a very good point. And I think it's fair, right? It's a fairly new industry, I think, considering everything, right? So René, that was the warm-up. Are you ready to go?
I'm ready to go. So I have 30 minutes on my timer, right?
Yeah.
Okay. So let's go with it, because I have a lot.
Go on.
Okay. So welcome everybody. So this is a presentation on when we are down is not good enough. Site reliability engineering in Azure. It's I apply for the longest title of today. I don't know if I won a GitHub figure here, but it is definitely a long title, and there is a lot to tell. So I will get started very quickly. So normally I will do this in an audience, in a live audience. I will ask people to stand up and have a count with me. But since I don't see any of you, I don't even know if people are actually around. I do this count. And that is 4 seconds. And 4 seconds is what you have if you have a 99.9% SLA with your customers. 4 seconds, or actually 3.6 seconds, is what you have of downtime in an hour. So it's only that short. 4 seconds, and then you are violating your SLA. And why do I tell it like this? Why do I show a percentage and tell about the 3.6 seconds? Because this table that I found in the SRE handbook that was written by the engineers of Google, this really opened my eyes. This was kind of an epiphany for me. Because when you see this table, things like we need to have a 99.999% availability or uptime actually doesn't make a lot of sense if you're in a company that is not much automated yet. Because what it actually means is that if you if you pursue a 99.99% SLA, you only have 8 seconds a day to be down or not available. If you deploy a new website to an Azure web app, it actually gets slow or even is down for maybe 3 or 4 seconds. So if you do 20 deployments a day, you will violate your SLA. So this table actually makes you realize that it's not so simple to be up and to not have downtime. Because if we look at what down actually means, it's a lot of things. It's not only a 404, or it's not only a 500. It's a lot of things that the customer can experience, because it is in the end all about the customer. It is not about the software components. So how reliable is your site? Does your site do what it has to do? Does it meet the expectations of the client? But also, is it available? Can you actually reach it? Is it up or down? But also, can it actually process all the data that you put into it? So if you put a lot of data on the one side, is the same amount of data processed on the other side? And is the data correct? And is it fresh? And is there not a lot of latency? So all these different components that actually make up the component reliability is actually mean that you can be up or down in the eyes of the customer, although you are maybe not up or down. So yesterday I tried to log into Teams yesterday evening because I had a meeting, and Teams was down. It was actually Azure Active Directory that was down, but some people could log in, but for me it was down. So did they violate the SLA? Yes or no? So that is what down is all about. And if you look at these percentages of 99.9% and what it actually means to meet those percentages, like 3.6 seconds in an hour, you can also a little bit more grasp the conflicts that operations people versus development people constantly have. Because it's usually the operations people that are responsible for keeping the site alive. And it's the development people that are actually responsible for delivering new features. But if your KPI is, well, meeting the 99.99% SLA that we all agreed on because it sounds really, really nice, you can actually understand why people are a little bit hesitant to change. And of course, they will never actually say that they won't allow change because they otherwise won't meet their KPIs. It's always the sugar-coated version of that stuff. So what we hear from ops is usually like, we have to launch review first, or we have this architecture board that we need to have approval on because we need to see the impact of these changes. This is the management change list that you have to go through. So please make sure that you check all the boxes, or we should first validate it really, really thoroughly in test and pre-production. So there's all kinds of excuses, apologies, but also real life concerns of people from operations because they don't want to violate that SLA on the site. On the other hand, we also have the sugar-coated versions from developers that say, well, it's not a real change, it's just a feature flip. It's only a hot fix or a UI change, and it's only a 20% experiment because they have a different KPI. They have the KPI, they have to deliver new features to the business. And that's what they have in their bonus package if they deliver a lot of new features. But in the end, if you look at the goal of a company, it's delivering great IT services to your customers. And that is, on the one side, reliability, reliable systems, and on the other side, systems that actually do what the customers need the systems to do. So the right features, build in time, delivered frequently, etc., etc. So the conclusion of this all, and that is hopefully not new for you when you are on a DevOps conference or meetup, conflicting KPIs do not work. So the same goal result often in conflicting KPIs. You need to keep the systems 99.9999% up, and you have to deliver new features, and that is a conflicting KPI, although we pursue the same goal. And that is not new. It is so not new that about, I think, 10 to 15 years ago, we saw a parallel movement emerging. So on the one hand, we had DevOps, and on the other hand, we had site reliability engineering. And they actually started out in the same era. So like 10 to 15 years ago, we started with these two movements. So on the one hand, we have the thing that we maybe know and love already is DevOps. It's the union of people, process, and products to enable continuous delivery of value to the end users. So that is a concept of how we should work together as an organization, how we should work together as developers and operations people, how we should implement our processes to be a little bit more lean, to reduce the handovers, and to shrink or destroy the wall between the different parts of our organization, and use the products that we have, like automation, tooling, infrastructure as code, etc., to enable that continuous delivery of value. That is what we know of DevOps. And what we also know of DevOps is that there is a lot of practices and tools around there, but there is no real Bible of this is how you do DevOps. It just is all these concepts, it's culture, it's automation, it's people, it's a lot of things together that make up that concept of DevOps. At around the same time, and that is maybe a little less known, was Google. And at Google, they started to grow really fast, and they also understood that if you have to run a cloud infrastructure, that ITIL and waterfall processes and handovers and a lot of manual work is not actually working if you have to redeploy 10,000 servers at the same time. So they gradually found out at Google that, well, the processes as they were implemented in many companies back then were actually not as functional within Google. And they asked Benjamin Traynor-Sloss, that coined the term SRE, that say, okay, well, we have to have an operation teams that actually works like a group of engineers that actually is automating stuff and approaching operations from an engineering perspective. So this is what he said about what is SRE. It's when you ask a software engineer to design an operations team. And when we dive a little bit into the definitions of site reliability engineering, we can see that it is an engineering discipline. So that is an important word here. So not coincidentally, the words that are important are made green. So site reliability engineering, it's a discipline devoted helping to sustainably achieve the appropriate level of reliability in their systems, services, and products. So what do we mean by sustainably? It needs to work for one server or for one service, but it also needs to work for thousands or 10,000 servers. You need to grow, you need to scale your level of service that you have to offer to the organization. What's also a very important word here is to achieve the appropriate level of reliability. We already took a look at reliability. It is that combination of availability, latency, downtime, all that stuff that we showed in the first slide. But the appropriate level is also very important, because not every system has to be up 99.9% of the time. Not every system needs to be up 80% of the time. If you have an application that is only used by office workers from 9 to 12, because, well, that's the process, the rest of the time you don't need to maintain that uptime. And what we see a lot within organizations is that they have to find this all over SLA percentage, like 99.9% for all the systems, while that actually reduces a lot of flexibility within the organization. So appropriate is very important to say, this system, what is the level of service that we actually want to guarantee here? So if you look at SRE versus DevOps, you can actually say in coding language, SRE is an implementation of DevOps. So DevOps is more talking about concepts, abstract concepts, like you need to do automation or you need to have teams working together, while SRE is really describing more practices and say, well, this is how you how you implement the practice of a site reliability engineer. So it's much more, well, concrete, as you might say. If we then look at what is it actually that an SRE does, well, and how does it relate to what a product team does? You can, well, say an SRE, a site reliability engineer, focuses on the reliability of your site. So that means that if you have a product that needs to be up 24/7, for example, Google, or a application that you can use to do banking services, you have reliability problems all the time, because especially when you're in a cloud environment, it's never stable. There is always something going on, and well, there is latency. Things happen with the cloud provider. Things happen. Maybe you get DDoS. So SRE, its sole focus is on the reliability of your site and to make that better. So product teams focus on the business value. So they produce features, they produce new functionality, they fix bugs within the code. And usually they do not focus that much on performance or latency or all that stuff to make the product reliable. And the SRE, that's an expertise that can be embedded within the team, or if you are maybe bigger, there is a separate team of SREs. It doesn't really matter where you place them within the organization, but the role SRE focuses on the reliability parts of your site, while the product team focuses on the business value of your site. Important here is that they share the ownership. So it's not like the engineers produce code, throw it over the wall, and then, well, it's the SREs. And well, that is the example that I gave in the introduction when Rasmus asked me, where did you work with SREs? In many organizations, the SREs are just a new name for the ops people. So they are still the ones that have to get out of bed when something happens. They are still the ones that are doing the releases. And then we have the database SREs, or the infrastructure SREs, or the network SREs. That is usually a bad sign. That is, we are renaming our ops people into service site reliability engineers. A site reliability engineer is an engineer, and they share the ownership with the product team, and they are as much responsible for keeping the product alive and delivering new features as the product team is. You can embed them in the product team, or you can have them outside of the product team, but they share the ownership. And they are all engineers. And that is really, really important. It's not a new ops role. So how do you manage that? So if you have that shared responsibility, so how can you actually make sure that that conflicting KPI part that we talked about in the beginning is not in the way of what we want to achieve here? And this is where one of the things that comes from the site reliability engineering books, SLIs, SLOs, and SLA comes in. So let's start with the SLIs. In order to make sure that you are measuring the right things and that we are talking about the same things here and that we can have that shared responsibility because we know that the things that we are talking about is that same thing, is the service level indicator. So service level indicators are a ratio, proportion. And you can, for example, say the number of successful HTTP calls divided by the number of total HTTP calls. And that is a ratio, or the number of operations completed in less than 10 milliseconds divided by the number of operations. That gives you a ratio, and that can give you very clear objectives in what do we actually want to achieve here. So this is the number of HTTP calls divided by the total. And what is also very important, and that is in yellow, you need to really define where you measure it. Because if you measure it at the client, you can have totally different result as that you measure it at, for example, the load balancer. So you define SLIs as, well, the number of calls divided by the total number of calls, and you measure it by the load balancer. Once you have defined a set of these service level indicators that you define with each other, you can create service level objectives out of them. So a service level objective is what do you actually want to achieve? So the thing, for example, HTTP requests, the proportions are successful in 50% of the time, or can read the data in 99.9% of the time, or returns the calls in less than 10 milliseconds in 90% of the time. And the measurement in time scope, for example, in the last 10-minute period, or in the last month, or in the last week. And this is also important when you are going to define your SLOs together with your customer or internally. If you say this is measured in a 30-day window, you have more time to make mistakes than if you agree on in the time window of an hour. So if we take the example of the 3.6 seconds that you have in an hour to be down, if your SLO is defined on the hour, every hour you get a new 3.6 seconds. But if you define it by day, you have, well, 24 times 3.6 seconds that you can actually use to make some mistakes. So that is also a very important thing on how you define the time statement. And this SLO serves as an agreement between the product team that wants to deliver features and the site reliability engineers that want to keep your system performant and reliable, and of course up in the air. So how does it relate to an SLA? Well, if you have a number of SLOs, you can also create an SLA out of it. And the SLA is nothing more than a commercial agreement with the customer. So for example, we have an uptime and the SLA is a little bit less and the SLO is a little bit further away. So maybe internally we have more strict rules on what we want to achieve than that we agree on with our customer. So that we have a little bit of room to actually make mistakes without legal impact, for example. And that brings us to the next thing. What do we do with this SLO internally? So for example, when we define an SLO of 80% of the calls is successful, we can say, okay, well, this is 80%. That means that if we have more calls that succeed, so we have, for example, 95% of the calls that succeed, it gives us an error budget. It's not only working one way. It's not like this is the 80% and it can always be higher and not lower. No, an SLO serves both ways. So we can say we can have more room to experiment. It gives us a sort of error budget. So in this case, when we have an 80% SLO and our real target is 95%, it means that we have 15% more time to experiment, to make more errors. Or maybe 100%, then we have more time to experiment. But on the other hand, when we have less time to experiment. So, for example, no new releases with features. And that makes the agreement between the site reliability engineers and the product teams very clear. As long as you keep your SLO, you can do whatever you want. You can experiment, you can do new releases, you can do feature toggling, you can do new kind of pipelines, you can do whatever you like. As long as if you don't violate the objective. If you violate our objectives, not yours or mine, but our objectives, we need to focus on reliability first, and we need to get that uptime up above the SLO again. And that is a really clear way to communicate about what do you want to achieve. So for example, if you look at Azure, you can use, for example, log analytics to make these SLIs and SLOs really visible to your product teams. So in this case, I had a website and used application insights. They measure a lot of stuff for my website. And then I can create simple queries like, okay, the requests, where the timestamp is within a few days, and do some calculation there. And then you can say that the green line is my SLO. As long as we are above the green line, then it's totally fine. If we drop beneath the green line, then we have to take action and we need to work together to make the site more reliable again. And log analytics and the queries that you can create in log analytics can create these graphs very easily for you and make it insightful. So then we take a look at what does an SRE actually do. So an SRE works on two things within the time allocation he has. On the one side, she works on operational works, so incidents, tickets, operational work, just like the stuff that you can compare maybe to normal operations people. But on the other side, the 50% that is left, they work on project work, things that they can do to actually improve the processes. So automate that thing we always do manually. Make that website a little bit more reliable because it raises a lot of exceptions or errors. So stuff that actually reduces a lot of toil. And toil is manual, repetitive work that is automatable, tactical, and not delivering any value. And the worst thing about toil is it scales when the service grows. So if you do something now, well, you have to restart a server every once in a while. If you have 20 servers, you have to do that 20 times. So it takes a lot of time. So toil is that projects that SREs works on in the time that is left. They are not working on operational work. The great part is that if you also define that line of 50% project work, 50% operational work, when there is more operational work, there is more tickets, the work will happen in the product teams itself. So the engineers that are working on features then need to jump in and do operational work because there is so much work to do. There is so much stuff going on operationally that, well, obviously there is something wrong in the system and the engineers need to start, well, scaling down the work at first and then start working on solutions to actually make that work, less. So project work is automating toil, getting that repetitive work out of the way. In the operational work, it follows a little bit of a cycle. So detect, respond, remediate, analyze, and readiness. So let's go through a little bit of these examples. So in the detect phase, we are building stuff, we are doing stuff in our regular day-to-day basis. Are my apps and infrastructure doing what I actually expect? And are my apps and infrastructure doing what others expect? And we have three kinds of monitoring output that we can use here. So on the one hand, we have alerts. Well, something is really wrong. We have tickets. Well, it's not bleeding, but things are wrong and we need to look into it. And we have, of course, logging. And normally you won't look a lot at logging, only when something is wrong. So it's usually something that is very verbose. There is a lot of it. And you don't want to scroll through log files just to see what's happening. That you want to have the right alerts from your log files when something is wrong. Because when you have alerts, tickets, and logging, you need to go through the next phase, and that is respond. And what is important to consider when you are thinking about responding, you need to respond to the right things, because otherwise you are just scrolling through log files and you cannot find any good information. So when you create alerts that are actually helping you to look at the right things, you need to create actionable alerts. So alerts are really there to help you stay focused. Alerts are not logs or notifications or heartbeats. Everything that is normal is not an alert. An alert is also something that needs a human to investigate. So if something can be automated by calling a webhook when something happens, restarting a server when something happens, maybe you should write a small program, for example, a logic app that says, well, restart that server for me if it's something that we need to do constantly. And you need to have written down the crucial details on where does the alert come from, what expectation was violated, what do we expect, and what was the behavior that we see, and why is this an issue? And also with log analytics, you can create all kinds of stuff. For example, this is the number of sales. When it drops below the blue line, or maybe tops over the blue line, we want to raise an alert. And also in Azure, you can create automated alerts. You can react on these kinds of log analytics queries, and then you can define an action group. What do you want to do when these alerts happen? For example, you can create a webhook, or you can send an email, or you can send a text message, or you can create a logic app that you can call. For example, when this alert happens, we want to create a Slack channel with all the information about the event that just happened in the Slack channel itself. When you have responded, you have to remediate. And this is where continuous delivery really comes in. Because continuous delivery is always mentioned as that thing that you use to deliver new features. But continuous delivery and automation is also something that you can use to decrease your mean time to recovery. Because if you have to deploy something and it takes you a lot of manual work to deploy a bug fix, then, well, your mean time to recovery drops or actually goes up. So continuous delivery is something that is not only for the engineers that are building features, but it's also for the SREs that are actually want to deploy bug fixes or new infrastructure. So automation and pipeline automation also comes in on this part. When you have fixed the problem and stopped the bleeding, you need to start analyzing. What are you doing here? So you want to, for example, do a blameless learning review. You want to involve everything. After the event that something happened, you want to involve everybody that was involved, do it as soon as possible and focus on what happened. Make it blameless. Talk about facts. What happened then? What information did you have at hand to make this decision? What did you know? What did you not know? And what sense did you make out of it? And you can create a timeline of a whole incident to actually start analyzing the thought process behind it and see, well, this happened because, well, something was not in order here, or we did not have this information and we made the wrong decision there. And then you can start doing the same thing. Well, you can start implementing in a project fixes for the problem. And then the last step, you need to be ready for the next time, because mistakes are meant for learning and not for repeating yourself over and over again. So you have to do the structural fix. So once you have analyzed it and you stopped an incident, you can also create a structural fix for it. You can also simulate it by something that we call for the pull attack. So that person in your team that knows everything, that knows all the credentials, that has access to every system, knows about the domain a lot, just do a simulation and take her out of the team or take him out of the team. And then see what happens if that person is not around. And you can learn a lot from those. Then we have response training. So game days, red teams, blue teams. What happens if we crash the server? What happens if we shut down this application? What do we see happening, and what can we do to fix that? Of course, the on-call rotations rotate between SREs, the people that are more operation reliability focused, with people from your product team that are actually more feature focused, and start learning from each other. And start doing some chaos testing, for example, testing production. What happens if we do this in production? So there is a lot of things to actually prepare you for that next phase. So to wrap up, it's a long talk in 30 minutes, but consider your SLAs carefully. So just do not define only 99.9999%, but really think about what do we want to agree upon internally with an SLO or externally with customers. Site reliability engineering, and I hope I made that message clear, is not a new operations department. It is a skill, it's an engineering skill, and it's people that, just like the product teams, focus on the product, but only from a reliability side of things. Use SLOs, define them very correctly, and use your error budgets to actually start experimenting and learn. Start measuring everything, because you don't know what happens, and observability and measuring everything in your system so that you can later relate to this happened because of that is very important. So measurements and monitoring is very, very important. And do a close of the incident with a good learning review. Make it blameless and analyze what happened so that you can actually improve your processes. That was it for me. My name is René. If you have any questions, I'm also at the panel. Thank you very much, and I hope you enjoyed it.
I sure did. Yay!
Yay! Thanks for that.
Thanks,
Nice.
René. It was awesome. And I hope everyone out there enjoyed the show. Feel free to leave a comment for René here. I feel that you're very passionate about this topic, René. So also that it's shining through here today. And I really love the fact that it's a skill, right? When you say it's a skill, because it also means that it's something you can acquire. And could you point to some good learning materials out there?
Yeah, I think it's really the upside of DevOps. You can almost call it. So let's say be very fluent in things like PowerShell or Bash or script languages, Azure CLIs. Be fluent in infrastructure as code, but also know a lot about security, and not like security in the sense of compliancy. This is the rules you have to follow, but more in how can we actually detect stuff in our systems that is maybe invisible to us? How can we actually automate stuff to automatically and proactively give answers to attacks or stuff? So make monitoring, dive into monitoring. That is a lot of things. So application insights, PowerShell scripting, security center, a lot of the security features in Azure. That is a lot of stuff that you really have to know a lot about to actually make your systems more reliable. It starts with the insights, right?
Yeah, good stuff.
Yeah,
Thanks,
it all
Renee.
goes back to the toolings.
Yeah.
Get to know your tools. So there are a lot of things out there that you can use. They're available for you, but you might not know exactly that what they do. So get to know the tools.
Yeah. Thank you.
Awesome. Renee, hang on. We will be right back with you in just a few seconds. So, well, that was 3 talks.
Yes.
That was pretty exciting, and we did it in less than 2 hours. So everyone, thanks for hanging on, right? So we still about a good handful of people on the stream, and it's been fairly consistent throughout the morning here. So we have 2 more elements on the agenda for today. Next up, we will have the panel, and after the panel, we will just close up, and we have some prizes to give out, right?
Yes.
So hang on. Hopefully you caught the secrets.
Yes.
We still have a mountain of swag in here in the studio, so we need to get rid of it.
Yeah, we don't want Osmus to have all the slides. It's okay if I have it though. But
I don't need any more Maersk ships. I have those.
That's true. That's true.
So I really appreciate you hanging on there. So now we will invite our presenters back in. We had some good questions throughout the morning here, and we will bring up the questions, right? So just before we do so, we will pick a couple of questions that will win prizes for today. So not everyone gets a prize, sadly, because there's a lot of questions. But just keep them posting them, right? It can be general questions for everyone or specific question for Renee, Vakas, and Bas. And we'll manage the handoff of gifts just after this. So hang on.
And before we bring the speakers back, maybe you can give them a virtual round of applause. You can use all the emojis there to give them a virtual round of applause. Unfortunately, we don't have our stuff in the studio. Otherwise, we could press a button and there will be claps there. Since we don't have it, so give them a virtual round of applause.
Yeah, use the chat, please, guys.
So, Vakas, Rene, and Bas, welcome back to the studio.
And Bas, here we go. So 5 people. I think that's the max you can be in Denmark right now together, right?
True.
So at least we're at least 2 meters apart, except you, of course, and me.
Yeah, me good.
But yeah, I think we are within the I don't even know what's called in English. The max you can huddle together.
Yeah, gathering.
Ceiling.
What to say in Danish?
Forsamlingslov.
Forsamling, the gathering. Yes,
But only the Danish and the Dutch understands that.
Yeah. And
Great.
we have Danish and Dutch on the
Exactly.
panel.
Yeah. So no problem. All right. So Bas, thanks for joining us again, Renee and Vakas. We have some good questions from the audience. So what we can do now is bring them up to screen. And I think let's I'm just browsing through the list here. So we have a question. I think this is for you, Bas. Let me bring it to screen here. So how do I get GitHub Advanced Security? And hopefully we will not discuss licensing here.
Yeah, so GitHub Advanced Security, so the features are free for open source. So if you have public repositories, then you can just enable the features and start using them right away. For code scanning to work, you either need to configure a GitHub Actions workflow. So if you use GitHub Actions today, you can just add in the steps to initialize the code scanner, and then you need to do a build of your code, and then you can execute the analysis, and that will provide feedback into the user interface. The other features like Dependabot and the secret scanning, they only need to be enabled. And then if you have private projects and you want to use, so for dependency management, that is also included in the GitHub plans. And then for code scanning and secret scanning, that requires an additional license, and that is also, it's a monthly subscription that is based on your committers, so on people that actually push code changes to GitHub. So that is the difference between like the regular sort of GitHub subscription, where you would just buy a subscription for all your developers. And so for code scanning and secret scanning, so GitHub Advanced Security, typically you only purchase licenses for the people that actually make code changes.
Yeah, which is the developer. Great stuff. Thanks, Bas, and thanks, Nick, for the question. Next one is for Vakas. Where to start? I think you try to get back to Anders in the chat though, but could you just reiterate where to start this journey?
Yeah, it was. So I tried to answer it, but only 200 words you can write or letters. So it's better to talk. Yeah. So in order for you to get started, I would say you should write down whatever you have right now. And once you have it on paper, then you can go to, I recommend Terraform because I myself use that. So you go to Terraform and see if there's some modules already present that you can use. You can also write your own if you want to, if they're not there. And then try to make that plan more look like, or the modules look like your plan. So once you have it, then start slow, maybe deploy a simple app first and see how it goes, and then add more on top of it. And then right from the start, you should be adding all of the code into some kind of version control, so like Git. And then you keep adding more and more stuff, removing stuff. Yeah, so start slow and then keep writing the modules if you're using Terraform.
Excellent. Thanks, Vakas.
Thank you.
And then we have one for Renee. These are good warm-up questions.
Yes.
So how can you elaborate on SLIs and the impact of business value?
Well, the SLI is a service level indicator, and well, what I also said in the reliability part, it's all about the customer. So I think that I don't know if it completely answers the question, but if you look at what do you need to define, there is multiple service level indicators that you can have around. So you can have some focusing on the availability, like my site needs to be up 99% of the time measured at the load balancer, for example. But it's also, you can also really do it with customer value. For example, only 80% of the customers can drop off during checkout, for example, measured at the web server. So if you have the business value, we want people to actually check out their products in their shopping cart, you can create a service level indicator around that and say, okay, this is what we need to start measuring. Because if you have that, you can also say, well, if the drop off is too high, we need to make adjustments, maybe in our performance or maybe in the functionality. So you are completely right. Some parts of the app are more important than others. I think there are technical SLIs that are really on the operational side of things, and there are business related SLIs that are on the feature level and on the usage level. And I think it's about defining the right SLOs in what do we actually want to deliver internally and to our customers, that we want to, that we can start measuring that and have that shared objective, because I think that is what it's all about. So I hope that answers the question a bit.
Excellent. Thanks, Renee. Good answer and good question, Richard. And actually, our randomizer says that you have won one of the prizes. So to claim the prize, you need to go write me on meetup.com. So where you signed up for the event, just send me a direct message there, and I'll get back to you with the instructions. Good stuff. Now I have more of a general question, and this is for the whole panel. So if this will go to each of you. So, and it's a fairly broad question. So what's your favorite part about DevOps and DevOps practices? And Bas, can I start with you? What's your favorite part of DevOps and the DevOps motion?
I think for me, the favorite part is just the people part. I think, tools are important, right? I mean, they can help us. Processes, yes, they need to be in place, but I think it's really about people and people collaborating together. So to me, I mean, in the end, we need to get work done, and most of the work, we have the tools that, that allow us a certain level of automation, but in the end, it's really the people that deliver software, I think. And to me, they are, and so I think having a strong engineering culture, having a healthy culture with your engineers collaborating together, being transparent and open, try to foster a culture of collaboration inside your organization. To me, that is really what is most important about DevOps.
Thanks, Bas. And you, Marcus?
Yes. So I would continue what Bas said. People, I agree that people are a very important part of that. To add to that, I think for my own sake, the tools that you use along the way, automating stuff as much as you can, and that's my favorite part as well. So I love to automate stuff. So if I'm doing something twice, then I would try to automate it as soon as possible. So I take the same technique in DevOps. When we are looking at pull requests, run as many as tests at that point, or never do manual deployments, use automated deployments all the time, or even infrastructure deployments, run them via pipeline. So I think this automation side is my favorite part in DevOps.
Automation for the win.
Yes. Absolutely. Thanks, Marcus. And Renee, how about you?
Yeah, I agree with all, but I like the process part. I'm a process person, and I don't like long handover processes where everything goes very slow. You have to wait, you have to use tickets to get what you want. So I love that enablement of people. So first maybe in a role that you start enabling others to actually start doing the work, doing the self-service, like Marcus showed with the Terraform stuff and stacks and modules and everything there. But I also, when people start making that transition in being aware that they can actually be the change themselves and like enable others to do stuff themselves instead of doing that for them, reducing the handovers, using automation to actually start enabling and to be self-provisioning in everything that you want, and do not need others to actually get to the end and then deliver value in a day from scratch. At the end of the day, you have something up and running because you can do everything yourself. You don't have to wait. That is the motion that I love most, when people get to grasp that.
Yeah, and a very powerful one. So I think Amazon and Jeff Bezos coined it very well in a few more words than I will say here, but he said any team providing a service or a capability to others must do so in is self-service and automatable fashion, right? That actually frames it very well. What we're trying to do here is, if you want to empower others to be self-sufficient, well, that happens through automation. So just a good roundup here. So we actually have a very good question here from Robert, and I will go again around with you all. So what is the biggest challenge you have seen with implementing a DevOps mindset, and maybe the solution? So Bas, would you mind going first?
Yeah, I think with this, I think I'm back to people again, because culture change is such a hard thing, right? A lot of, if you have teams that have been building on a product like for a long time, they have practices, and they might not always be the best practices, right? And it's really hard to sort of bring change. And I think for organizations, if you have the ability to continuously sort of improve yourself, I think that is a really strong value that you can have. But it's also one of the hardest things, is just making people change themselves, or also making people take ownership of their work, and be open to a continuous improving the way you work, the way you collaborate together, the practices that you're using, the tools and technologies also that you're using. So being open to also improving there. I mean, it's continuously changing all the time. So I think that is the biggest challenge.
Excellent. Thanks, Bas. Marcus, same to you. Biggest challenge?
Yeah. So actually, Bas, what Bas said, I've experienced that in the past as well. So people don't like to change, right? So whenever you bring this kind of change in the team, which is doing only the dev part of the whole DevOps chain, people don't like it. So it's the biggest challenge is putting it into the culture of the organization. And it's not just the developers, it's the whole organization runs around DevOps. Then you can really make the things happen. So you have to buy in from the leadership, from the other stakeholders, and then it kind of works together. So that's the biggest challenge I've seen, is having the teams, not only the developing teams, but other teams get into this DevOps mindset. And I think the way to overcome this would be to have make them attend conferences like this one, educate them, talk to them how it is done, and look at how people do it, look at the best practices. So yeah.
Excellent. Thanks, Marcus. And Renee, your opinion, please.
I think I have a whole presentation on growing your DevOps mindset. It's an hour or so. So there is a lot to say about this, but I think it starts. It's two things. So I think it starts with a change process that you have to go through. So I always use the EDGAR, like awareness, desire, knowledge, ability, and then the reconciliation. So that's the process that you have to go through as a person, as a team, or as an organization. So you need to put things into place there. But in order for people to actually have the desire, you have to make them aware. That the awareness part is easy, but the desire to actually make the shift comes from, maybe lack of knowledge. You can also do that. That's also not too hard. But I think a lot of companies struggle with this physiological safety stuff. People don't dare to try. So people have a barrier to actually do stuff and start doing, instead of thinking about it and making great designs or great pictures on how it should look, but actually just pick up the gloves and start working and try stuff and feel about it. That is a big barrier for people. And I think that the biggest barrier that you have to overcome within an organization is to take away those barriers. So sometimes they really exist, then it's hard, but it's doable. But in most cases, they do not exist. They only exist in heads of people, that they are so used to doing the stuff they need to do. And you need to really take away that barrier of you can try stuff, it's safe to do so, you're not getting fired when failing, etc. So and that whole process of making people into the groove of trying stuff, I think that is the hardest part. Once you have that knowledge, skills, all that stuff is easy to do, because then you're in the right mindset to start consuming new information. I think that is it starts with the base of trust.
Good call outs. Thanks, Renee. Thanks all. And actually, my randomizer says that Robert has won a prize as well. Robert, same instructions. Find me on the meetup.com platform where you registered and send me a direct message.
If you don't do that, he will keep the slides. We don't want to do that.
Yeah. I will feed it to my pets. All right. This one for Vakas here. Could you please describe your automated testing strategy for infrastructure as code?
So I also posted a link to one of the tools that you can use in the chat. But the way we are testing is that we have a lot of custom modules written, and then we are actually testing whenever someone is contributing a module. We are running multiple tests around it, which test different things, and we there's something called unit tests, if you're familiar with. So we're running some unit tests on top. So before it makes into the registry, there's multiple test runs that happens. So it's really custom things that we have written specifically in our own case. But you can go to the link that I posted in the chat, and that is specifically for Terraform. So you can take a look. There are 2 different kinds of tests. You can look into those, and you can apply those as well.
Excellent. Thanks, Vakas. Next one is for Bas. How secure are the third-party functionalities provided within GitHub and GitHub Actions?
Yeah, I think that is a really good question. I mean, so with GitHub Actions, you can build pipelines that include like third-party actions, so actions that are written by community members or tool vendors. And yeah, the question really is like, okay, how secure is it? It's similar to like consuming open source, right? I mean, when you consume open source software, that software is not maintained and controlled by you, but it's controlled, and maintained by, open source community members. So in that respect, there's a similarity between using third-party actions on GitHub. But then at the same time, so we do have verified tooling vendors. So a lot of vendors like HashiCorp, for example, or Microsoft or Atlassian, so they are verified as third-party vendors. So that is one, at least one thing that can help you to sort of, judge whether it's safe to use a third-party action. The other important part is to always make sure ideally you should sort of review actions, third-party actions. So look at how many stars the project has. Is it well maintained? Is it used by a lot of others? And then make sure that you always reference a particular release. So with actions, there is we have best practices on how to publish them. So make sure to always consume a release. And then we do have a bunch of sort of security capabilities built into the GitHub platform that you can use in order to control what actions do you allow inside your organization. You can completely sort of disable them, but you can also control. You can, for example, only allow verified, so actions from verified vendors, or you can also whitelist, for example. So maybe ideally in an organization, you would set up some review process, and then you could sort of whitelist actions that have been reviewed to make them available to your developer community, and then make sure that there is like a low entry, easy workflow. So like either you're using Slack or Teams or using GitHub, where development teams can quickly sort of request access to certain third-party actions. And if you make that like a low friction sort of flow, then I think you can have a real good workable solution where all the third-party actions that you actually use are sort of reviewed inside your organization. And then you can use Dependabot, for example, to help you to keep those actions up to date.
Excellent. Thanks, Bas. Thanks, Richard, for the good question. I think we have time for just one more here. And the next one I will direct towards Renee. How do you convince the ops guys that they now needed to become developers or at least grow a dev mindset?
I think don't. Convincing people with arguments that matter to you usually is not a very good strategy. What helps is defining a vision. Where do we want to go? How does the future look like within 2 years within our company? So I think a few weeks ago, I presented a vision on the company that I currently work for. This is how we are going to deliver software in the new era. So we are doing flexible infrastructure. People have self-service portals that can actually deliver a new version to their infrastructure, or at least not in their infrastructure, but at least for them to use. And I was talking about that vision on this is what we are going to do, and then we have this all automated, and we get this automatically, and then all of a sudden the person sitting next to me was saying, but that means that my work is going to disappear. I said, exactly that. And you can do something about it, because this is what you need to start doing then, because your work, building up servers manually, or moving storage racks from one data center to the other, that is going to disappear. Maintaining Windows machines, that is also going to disappear. Your future lies in automation, in engineering, and you need to start doing that. And I think by helping them to understand the future, where it's going, people need to make that switch themselves, and do not try to convince them that much, because if they are not ready for it, they won't listen to you anyways.
That's a very good point.
Excellent. Thanks, Renee. And I think we have a third winner here. Alan, congratulations.
Yeah.
You won a prize as well. Same instructions for you. Ping me on meetup.com. I'm the organizer for this event, and I'll get back to you with instruction on how to claim your prize. So, panel, thanks a lot.
Yes.
You were awesome. As a panel, you had some awesome speaks. I'm just going to bring some of the comments from the chat to the screen here. There's lots of them.
Yes.
And they just go on. So I think the audience has really appreciated your presentations today. And even though this is not the perfect setting for a conference, we would much rather have more interaction and more time. I think we have some good feedback we can build on here. So speakers, thanks again.
Yeah, thank you
and have a great day, okay?
You too.
Thank you.
Thanks for having us. Thanks.
All right. So with that, it's just you and I.
Yes. So first, let's people how they can get their the other prizes.
Yeah.
The secret of.
The super awesome prizes. So I hope you had an opportunity to collect the secrets. Let me just bring up the instructions. So during the day, you have seen three different secrets during the presentations. And if you collected all three of them, you can now claim your opportunity to win one of these two awesome Lego vessels with a nice Maersk logo on them. I have one at home. It's actually quite big. And it's almost become like a team thing to have one of these ships in the background. So rules apply, right? EU shipping only, must be 18 years old, only one submission per person, and please only one, because I have to sit and draw and submit today. So let me just post the link here in the chat as well. So it should be coming through now. You can also scan the QR code here. So it's multiple choice, right? You have to guess the right secrets, and of course enter the email and your name, so I know how to reach you. And I'll get back to you tomorrow or one of the days after.
Are you going to sail with the ship to deliver this?
Yeah, absolutely. I would. but sadly we have Corona. Otherwise, I would definitely sail there with a real Maersk triple
Yeah,
E.
that were fun.
And I think just to put that in real life context, if you ever seen pictures or seen the Empire State Building, yeah, if you take one of these triple E's and put it on its tail, it's about that size.
I have an idea.
Yeah.
When we are done with all of this Corona situation, pandemic, maybe the next DevOps Secrets can be on a Maersk ship.
Oh, that would be awesome. The thing is
Talking
that
about containers all the time.
they don't sit still for very long, right? So maybe we should do it by the sails, and you'll fix the internet connection on the ship, right?
No, but we are all going to be in the same place.
Oh yeah. We will rent a couple of containers and just be in them. That's going to be comfy. There's one more chance to win a prize. So we also have our survey. It's I think 4-question or 5-question survey. If you take more than 2 minutes to fill it out, that's because you're doing a really good job, but it's going to be difficult. So please give us some feedback, right? As with all the community stuff we do here, it's a full refund if you're not happy. So give us some feedback on the overall experience. Was it relevant for you? And if we were to do it again,
yes, that's a good question.
what kind of topic should we take up?
Yes.
Right?
Because this is an event for you, and then we are exactly delivering what you're asking for. So it's really good for us to know what exactly you want to know. So please give the feedback to us, and yes, and then we are going to contact you how to get your swag box, and that is going to be to me. You don't want me to keep all the swags.
So there's an option field in the survey if you want to be eligible for a swag box.
Yes.
You just put in your email address, and we'll get back to you on how you can claim your swag box there.
Yeah, only if you want to have the swag box. Otherwise, you can be anonymous.
Yeah, we just like to hear from you, right? And give some feedback to the great speakers we had today. So with that, I think we have a few things left here. One thing I was wondering, is there anything else going on in the community that we need to know about?
Yeah, actually, funny enough, today is a DevOps day. So after here, I'm going to drive back home, and then at 3 o'clock we have a dev show, and today is going to be focused on DevOps, security in DevOps. So if you want to continue your DevOps journey, you can join that one. But apart from that, actually tomorrow, if you would like to build a robot with your .NET skills, we have Pete, one of the MVPs. He's going to join the Maker Show at 4 o'clock, and he's going to show you how you can build a robot. Apart from that, next week we have a climate hackathon going on. And the climate hackathon, it is the important part about it is that all the challenges that they come to the hackathon is brought to you by all the nonprofit organizations. So whatever that you do there is going to be 100% hack for good. So you can come as you are, because anyone has something to add. You can just, if you don't have a team already, you can find your team there. And I really encourage you all to join it, because that is literally going to be my favorite event of the year, apart from this one.
Of course.
So join us there at the Climate Hackathon, and we all going to work together to fix one of the biggest issue that we all have in common, which is the climate issue.
So true. So true. So Sherry, thanks for joining me today. It's been a lot of fun doing this, and the support from the community have been great. So everyone, thanks for joining.
Yes, thank you to you as well for inviting me to be here. And thank for you all that you're still watching us.
Yeah, I know. But yeah, I think the support has been awesome. So a big shout out to everyone there.
Hashtag thank you to all of you.
Great. So everyone, have a great day and see you next time.
Bye-bye.